Good day, this is the Professor, CBMD PhD, and today's Thursday, September 14th, 2023. It is 7:53 and 45 seconds, p.m. Eastern Standard Time, and today's research, saltwater taffy. So let's hop to it here. The sweet physics of saltwater taffy, tiny oil droplets, and air bubble supply, the sticky summer, staple, with its signature chewiness. Date September 12, 2023. Source: American Institute of Physics. The saltwater taffy product that contains no actual salt water is neither fully solid nor fully liquid. Researchers put the sticky, sweet confection to the test to understand the physics behind this unique candy. The researchers break down the ingredients and processes that determine saltwater taffy's material properties. When measuring how taffy responded to applied forces, researchers and their colleagues found taffy occupies the intriguing middle ground between solid and liquid material. As taffy is an elastic material, it has properties between a viscous liquid and elastic solid. Comparing the deformation behavior of commercial taffy to those of different laboratory-made sugar syrups and laboratory-made taffies allow them to identify the most important taffy ingredient, the material structure that governs taffy rheology. Despite the name the candy contains no salt water, conventionally taffies are made with table sugar, water oil, and corn syrup. Additional flavoring and food coloring provide a tasty and eye-catching effect. The mixture is boiled until it reaches a desired state, then cooled. Once cooled, the taffy is pulled by hand or machine for several minutes. The stretching and folding aerates and emulsifies the candy, incorporating small air bubbles and breaking down large oil droplets. As taffy is composed of oil droplets and air bubbles of various sizes, dispersed in an elastic matrix, sugar syrup, in some sense, oil droplets and air bubbles are like rubber balls. When deformed in the taffy, they tend to return to their original spherical shape because of surface tension. In other words, emulsification and aeration make taffy more elastic, hence chewier. The researchers found that air bubbles and oil droplets are the primary factors determining the rheological properties of taffy. Emulsifiers, such as lecithin, can promote the formation of smaller droplets and prevent them from recombining, leading to a chewier, long-lasting product. Armed with more information on how to whip up the desired candy, the researchers hope confectioners to develop new concoctions with textures and flavors while helping to maintain the traditional artisanship involved in confectionery. There may be another incentive to study the sweet, sticky stuff because the larger amount of soy lecithin compared to the commercial taffy. The laboratory-made taffy has a strong soy milk-like flavor, which they like. And this is a professor of space technology, advanced physics, mathematics, computer science, and leader of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.